Okay, so 1.1, we're going to talk about modeling and equation solving. Okay, modeling and equation solving. So first I want to talk about the numerical methods. Numerical methods, all right? So if you look at there, it says, this is on page 64. Scientists, blah, 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 okay. The most basic kind of mathematical model is the numerical model, in which the numbers are analyzed to gain insights into phenomena. So kind of like a guess and check type of thing. You just put numbers in and see how they respond and see what happens type of thing, okay? So let's get example number 1, tracking the minimum wage. The numbers in table 1.1 show the growth of the minimum hourly wage from 1955 to 2010. Table shows how the minimum wage adjusted to the purchasing power of $1996. Okay? So A, in what 5-year period did the actual minimum hourly wage increase the most? So can you look at the graph, or not the graph, look at the table and figure out in which 5-year period did it increase the most? Where did it increase the most? Anybody?
05 to 010.
Correct, 2005 to 2010, right? Because it actually had risen like $2.10. $2.10, right? B, in what year did a worker earning the minimum hourly wage enjoy the greatest purchasing power? So at what time did they earn the greatest purchasing power?
In 1970?
That would be 1970, correct. $6.47, right? That is the largest, right? Purchasing power in, so they are translating this into dollars in 1996, okay? Okay, so C, a worker on minimum wage in 1980 was earning nearly twice as much as the worker in 1970, and yet there was great pressure to raise the minimum wage again. And why is that? Because what's actually happening to the purchasing power? The purchasing power starting from 1970, 1975 to 1975 to 1980 has been decreasing, correct? Went from $6.47 to $6.12, $5.90. It was continually decreasing, and that's why there was pressure to raise it again. All right. Okay, let's go to example number 2. In example number 2, it says analyzing prison populations. Table 1.2 shows the growth in the number of prisoners incarcerated in state and federal prisons at year's end for selected years between 1980 and 2010. Is the proportion of female prisoners increasing over the years? What do you think? Is it increasing or decreasing? How would you calculate the proportion of female prisoners? In
average?
1990, how would I calculate the proportion of female prisoners? What is the answer there? Olivia.
You couldn't you take like the total for that year, like 774, and I don't know, put 44 for the female population over that?
Yeah, so it'd be 44 over 774, right? That's how you would calculate it. And you could calculate doing that, you could calculate every single year and find that out, right? So in order to answer the question that was posed to us, right, the answer is what? The question is what? Is the proportion of female prisoners increasing over the years, right? We have to, in order to find that trend, we would have to do that calculation for each and every one of those years, right? And if you do that, you get the following, the table underneath there, 1.3, right? So 3.9, 4.6, and blah, 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 right? So based upon that, what can you say? It is gradually increasing, correct? It goes from 3.9 to 4.6, 5.7, 6.7, 7.1, and then it slightly dips at 2010 from 7.1 to 7.0. But so in general, the female proportion of female prisoners have been or has been increasing ever slightly, right? Okay, so that would be how you use a numerical model to solve or answer a question. And an algebraic model is what we've learned all along, right? What we've learned in Algebra 1 and Algebra 2, how to use algebra to actually solve an equation, right? So in example number 3, it shows that a pizzeria sells a rectangular 18 by 24 inch pizza for the same price as its large round pizza that is 24 inch in diameter. If both pizzas are of the same thickness, which option gives the most pizza for the money? So in other words, this is what, example number 3. Example number 3, I have one rectangular that is 18 inch by 24 inch, or I have a 24 inch in diameter round pizza. So I have something that looks like this or this, okay? So the area for this one is going to be what? Nothing more than 18 times 24, correct? Whereas this one, the area is going to be what? How do I find the area of a circle?
Pi r squared.
Pi r squared, where r is going to be what here?
Radius.
Okay, so if the diameter is 24, what's the radius?
12.
12, right? So this is what I'm going to get. So on top, if I do this, the book says I get 432. Over here, I'm going to get, if I do this, I get 452. So obviously, to get that little bit more of a pizza, I would want to do the round one, right? Because actually, I'm going to get 20 inches squared more pizza than I would compared to the rectangular shape. Okay? So that's an algebraic way of doing things, right? So the next way we're going to talk about is the third way. So we talked about the numerical and we have the algebraic. The second is the graphical method, right? And hence, if you look at the title of the book, if you look at the book, it says pre-calculus, graphical, numerical, and algebraic, right? So we talked about numerical, we talked about algebraic, now we're going to talk about graphical. The graphical method, okay, the graphical method of doing this is what? So the graphical method, you basically take a table and you graph it, okay, and see what it looks like. So example number 4, visualizing Galileo's gravity experiments. So Galileo Galilei spent a good deal of time rolling balls down an inclined planes, carefully recording the distance they traveled as a function of the elapsed time. His experiments are commonly repeated in physics classes today, so it's easy to reproduce. And here is what the data looks like. Okay, so let's go ahead and see if we can bring our calculators out and see if we can actually graph this and reproduce the scatter plot that is shown in figure 1.1. So let's see if we can go ahead and put in our calculators the elapsed time. So the elapsed times would be in L1 and the distance traveled will be in L2. Okay, so let's see if we can go ahead and populate our calculators and do this. We've done this before, correct?
Correct.
Huh?
Correct.
Correct. Okay. So go to Stat, Edit, and your L1 and L2. Go ahead and populate them. Physically raise your hand if you were able to do that and get the scatter plot. You got it, Hunter? Okay. Caden's got it. Okay, that's good. Brooklyn's got it. Kyle's got it. Sam's still working. Sam is slow. Sam's got it? Okay.
No need to berate me now.
Consider yourself lucky that we're digital. Sarah, Christina, how are you doing? I need to unmute
Not
yourself.
yet.
Huh?
I'm trying.
Okay, all right. So you have to go to Stat, Edit.
Yeah,
Edit.
edit. Yeah.
Okay, and that'll give you the L1 and L2, right? You see the columns L1 and L2?
Is it like this?
Oh, you're still using that calculator. I told you needed to get the other one.
Oh yeah, I haven't get it yet, so
Okay.
I will get it.
Okay, I do not know how to work the Casio, so I can't help you with the Casio.
Mr. On?
Yeah.
After I input the two values, what button do I click afterwards?
Okay, so what's next? Now we have to plot it. We have to actually plot it, right? So you have to go to your mode and make sure that you are in the scatter plot mode. You want to find, in the mode, there's one that looks like this. You found that, Ezekiel?
Yes.
Okay, that's the one you have to be in. You have to select that. Once you select that, then you just graph or plot. Now raise your hand if you were able to get figure 1.1. Sam's got it. Oh, Sam's getting really quick now. Brooklyn's got it. Good.
I cannot find the plot insert button.
Ah, Hunter, help. Help Ezekiel.
Yeah, I don't have that on mode either, but I still got the graph to work. So
Ezekiel, what kind of calculator do you have?
TI-84 plus.
Okay, that's what I have. So I think if you go above the y equals, you have to press second and then the y equals.
I see.
And then
Yeah.
and then you need to press the first like little scatter plot looking thing. And then if it's off, you need to turn it on.
Okay, I have done that.
And then you just press the graph button.
It says window range error.
Ah, so your window is not set properly. What is your Windows at?
Let's see. My X minimum is -5. My X max is 65. My Y minimum is 66. And my Y max is 10.
Okay, so your y is incorrect, right?
Yeah.
Your y is the L2, and that needs to be in the range between 0 and 48, right?
Mm.
Going from 0 to 48. Okay, so I would go like y min as 0 and y max as 50. And I would do an x min of 0 and an x max of 10.
Would that fit on the calculator?
Yep.
Since the y goes up to like 78.
The y only goes up to 48. The distance traveled goes from 0 all the way up to 48.
Oh yeah, sorry, not 78, 48, sorry.
Okay, all right. Is it working now?
Give me a second.
Lila, were you able to do this? Okay, all right, we're good. Allison?
When I try and graph it, it pops up as invalid dim.
Okay, so in invalid dimension, that means that you have not this equal number of L1 and L2s. You have missed a point there somewhere.
Okay.
You have to know how to do this. I guarantee you this is on the test. Could anybody tell me why we are doing this? Why are we plotting these things? What are we trying to do? What is the utility of all this? We're trying
To learn how to graph using a calculator?
Well, we're trying to predict something, right? We're trying to predict something that we do not have data for, right? In other words, the elapsed time is 0 to 8, and then I'm trying to find out what happens at time 10, right? Because I don't have the data for that. If you ask me what's going to happen at time 3, I can tell you the distance traveled is 6.75 because I know that because that happens to be one of the points that I plotted, right? If you ask me what is the distance between at 3.5 times 3.5, I do not know that because I do not have that data point, right? So I'm trying to predict what's going to happen at a data point, a point where I do not have data. It's called, we're predicting, right? That's what we're trying to do here. Okay, so I'm going to assume that everybody's been successful now. And so that's what we're trying to do. And if you look at it, what does the scatter plot tell you? What does it look like? Does it look like a line? Is it like a curve? If it's a curve, what kind of curve? What does it look like? So here's the prediction. This is the modeling. We're trying to model this. We're trying to model the scatter plot. Does it look like a line? Brady, does it look like a line?
Are you talking about the scatter plot?
Yeah.
I wasn't able to get it on my calculator. I'm trying to figure it out.
What happened on the calculator? What does it say?
I think I typed the numbers in wrong.
Oh, okay. Caden, what does it look like?
It looks more like a line.
Looks like a line?
Mine does.
Okay, Sam, do you agree with that? Sam?
Sorry?
Does it look like a line to you?
Oh no. Does it look like that to you?
No, it doesn't look like a line to me. That's why I'm asking you. What does it look like?
It looks like
I
a
think my
shape.
Windows dimensions are incorrect.
What?
I think I cannot see the scatter plot at all.
Oh,
Or whatever it is.
okay. So you're gonna have to work on that a little bit, okay? All right, let me see. I'm gonna have to in the I need to get going a little further here. So Hunter, what does it look like? Does this look aligned to you?
It looks like kind of like a positive curve increase thing.
So it looks like a curve. It looks like a curve there, right?
At the beginning,
so
it's curved.
What we call this modeling technique is called a regression. So we're gonna do, if you go to these, there are many different kinds of regression that you can use on your calculator. So, and you will find that in Stat Calc. If you go to Stat Calc, there are like 10 or 12 different kinds of regressions that you can use, right? So Olivia, in your Stat Calc, when you go to Stat Calc, what is the very first one?
So I don't have my calculator right now.
Ah, you were just hoping that I wouldn't call on you.
Sure.
Brooklyn, what kind of regressions do you have there?
When I go to stat and then sideways to calc,
Uh-huh.
it says like 1 dash, I'm assuming variation stats.
Yeah, so you have one var stat.
Stat, and then it's 2 var stats.
Uh-huh.
And
keep on reading.
Dash med.
Huh?
And med dash med.
Okay.
And line reg.
Lin reg. Okay, lin reg. What's next?
Quad reg.
Quad reg.
And cubic.
Okay.
Cubic reg.
So it's linear regression, quadratic regression, cubic regression. What's after cubic reg?
Quart regression.
Okay. Quartic regression. Okay. What else?
Then it's linear regression, but it's different.
Okay. And what's the next one?
And then it's LN, so like line regression.
So LN reg, that is logarithmic natural log. That's not natural log regression. So and there's power reg, and then it goes on and on and on and on. Okay. So in this one, what you're going to use is I want you to try to use the lin reg first. So this is, we're going to assume that it's a line, okay? Sam thought it was a line, so let's see if it's a line. So if you do the line, do the lin reg, press the lin reg.
Are we doing the AX plus B or the A plus BX?
It doesn't matter, either one. Now, if you do that, it's going to give you an A and a B, and then it's also going to give you something that looks like this, an R squared. So what is the R squared value there? Caden, what was your R squared value for lin reg?
It only gives me the A and the B, 6 and -7.
Oh, it doesn't give you the R squared. And the reason why is because in your mode, not in your mode, but if you go to, oh, you know what? Let's not worry about it. Does anybody have an R squared value? No, nobody has an R squared value. Okay, so we're not gonna worry about the R squared value. Let's go to, actually, so what you want to do is, let's go to quad reg. Go to the quad reg, we'll go back to stat calc and do quad reg. Okay, if you do the quad reg, what do you get as the equation? You get 0.75 x squared and b is equal to 0, c is equal to 0. You got that? Okay, good.
Yeah.
Okay. All right, so that's what you're supposed to get. Okay, when a quad reg, which is basically a quadratic regression. So it's going to be, this is what you're trying to find. This is what it's giving you. Okay, so telling you that the A value is 0.75, B is equal to 0, and C is equal to 0, which makes this basically 0.75 x squared. Okay, so that's what you should have gotten. Okay, and if you do the R squared, it's going to be like 0.9999, almost exactly the same. Okay. So to get the R squared value, you have to go to your library. You have to go to your diagnostics. You have to turn the diagnostics on. You have to turn the diagnostics on, and I think that's in your, I think it's in your library. is how where you turn that on. Does anybody find that? Oh, it's a catalog. A catalog? Is there a catalog?
Statistics, like like stat diagnostics.
It is a stat diagnostics, yes.
It's just in mode.
It's
Like
in
on-
mode. Okay, so go to mode and turn the diagnostics on. Did you turn it on, Booker?
Wait, for my
Yeah.
calculator, how do I do that?
Yours is the same as hers, is it not?
She said I can't even say the word statistics.
No, I just went to mode.
Go to mode. Go
And
to
then
mode.
it's called
Yep.
stat
You have to
diagnostics.
scroll all the way down to where it says diagnostics
Oh, I see. And turn it on.
and turn it on. Now go back and do the stat calc and do the quad reg and see if you get an R squared value.
Oh, there we go. Isn't that dandy?
Okay, what did you get for your R squared value?
1.
1, exactly. That means that it's exactly follows that. Okay.
Oh, that's not good then. How do I change that value?
No, that's good. That's what you want. That's exactly what you want.
No, I have a decimal.
What's your decimal?
0.16, 8, etc.
Ooh, something's wrong there.
Yes, indeed.
R squared value, the highest you can get is 1. So go back to stat calc and do the lin reg now. Let's say that if you thought it was a linear, so do the lin reg and then tell me what the R squared value for that is.
0.9257.
Okay, so it's only 0.9257, right? So it is not as closely, it is not a linear shape is what it's telling you. It's not closely to a linear shape. It's more closer to a quadratic parabola. Okay, all right. So let's go ahead. I think this is a good place to take a break. So let's go ahead and take a break. And I'll give you 5 minutes and we'll come back.